Hi guys, welcome back to my YouTube channel. As promised, I've come back to do a lesson where we're just doing past papers so that it can help you to prepare for your exams. So for today, I'm just going to do questions that are Newton's first, second law, and an integration of Newton's third law. So before doing these questions, if you haven't checked out the videos where I explain the concept of Newton's first, second, and third laws, please check that video out before actually doing the questions so that you have the conceptual understanding. And then with the questions, I just prefer that, or I'd advise that you try them out by yourself before actually continuing with the video to see how I've approached them, so that you can actually interact and get to learn more from the videos. Okay, so today I'm going to do two questions from past papers for the laws that I've mentioned, right? There's a question here that I have on display. Before I actually continue to attempt the question, please pause the video and try it out by yourself and then see how best you can answer it. And then continue playing the video as I explain how I approach it and how you can possibly approach the questions. And then if you happen to have approached them in a different way, it's fine. You can just post in the comments, because sometimes there's more than one way of answering a question, and then I'll respond to see if maybe you have come up with a way that is also a correct possibility of looking at the question, right? The question says two blocks A and B are placed on an inclined rough surface that makes an angle of 35 degrees with the horizontal. Nceba is applying a force F on block A to push the system up the incline. Block B experiences a frictional force of 15 newtons, right? Then the first question is the easy one, the 2 marks of just recall that we should all get. State Newton's third law of motion, right? So when you're stating, we always say that there are key words there that you have to make sure are in your definition. But more than anything, it's best to just state it word for word as it is in your exam guidelines. So for Newton's third law, it says when an object A exerts a force on object B simultaneously exerts an oppositely directed force of the same magnitude on object A, right? That's 2 marks. And then they say draw a labeled free body diagram of all the forces acting on block B. So you will notice here that there's an applied force. So a force applied is what we call a contact force. It's not like gravitational force where you experience it whether you are on the Earth's surface or above the Earth's surface. This one is a contact force, which means when I touch you and I'm applying a force, you're experiencing it because your body, and my hand are in contact, right? So same thing here. There's a force applied. This F applied is a contact force, which means it's a force that is experienced by A, not B. But also between A and B, you should notice that there is Newton's third law, or action-reaction pair that is happening there. So block A exerts a force on block B, and block B also exerts a force on block A. These forces, as they've asked you for the definition, which is sort of leading you to think that there must be some application of Newton's third law in this question, right? So these forces are going to be having the equal or the same magnitude, but they're going to be acting in opposite directions, right? So A is going to experience the force due to B exerted by, or experienced by A due to B, and then B is also going to experience the force exerted by A, right? B, force acting on B is going to be in that direction. Force acting on A is going to be in that direction. So when they say draw a free body diagram of B, you must not forget to include the force that is exerted by A on B. Also, not making the mistake of adding the applied force, which is applied on A, to the free body diagram of B, because the applied force is a contact force, right? So let's get on to the questions. Some people usually just prefer writing down what they are given. So we are given the mass of A, mass of B. We are also given the kinetic frictional force experienced by B and the acceleration, which we are told in question 1.3 is 1.5 meters per second squared, right? So they say draw the free body diagram for B. This is B. I'm just going to draw it here. Let's do it here rather. 1.2, right? The gravitational force, since the objects are on an inclined surface, remember we used to just show you like this, where we say you can either draw FG going down like this, but FG is going to have components when you have an inclined surface. The one component, we call it FG perpendicular. It's perpendicular to the surface. And then the other component, which is FG parallel, right? Let me just bring this one this side to avoid any confusion. So the FG parallel is always acting down the slope. The angle, the 35 degrees, is here. And then that becomes 90 degrees, right? So if you look at the trig ratios, this is your angle, your 35 degrees. This is the opposite side. This is the adjacent. And this becomes your hypotenuse, right? So you'll find that if you are looking for either FG parallel or FG perpendicular, then you can use the trig ratios. So for instance, in order for you to calculate FG perpendicular, you have FG is equal to mg. So you can always use the adjacent and the hypotenuse sides, right? Which means you can say I can use cos theta is going to be equal to adjacent over hypotenuse. My adjacent is going to be FG perpendicular. My hypotenuse is going to be FG. So if I rearrange this to make FG perpendicular the subject of the formula, then I can calculate FG perpendicular using FG cos theta, right? Same thing if I'm trying to calculate sine theta, then now I can use sine theta is going to be FG opposite, FG parallel over hypotenuse, FG, which means if I want to calculate FG parallel, I can use FG sine theta, right? Now let's continue with our free body diagrams. Just a reminder that is going to help us when we are coming up with the components that I'm going to speak of here. So free body diagram, again, dot to represent object. And then I usually prefer to use the components when we are having a object on an inclined surface to avoid the mistake of forgetting to consider the FG parallel when speaking about the forces that are along the line of motion, right? So this, I'm going to give you both options. If you're going to draw the forces acting on B using the components of the weight, then you're going to have, they said the system is moving up, right? So I can choose up as positive. I can choose my direction of motion as positive. Now I'm going to have for B, I'm going to have the force exerted by A on B, right? And then I'm going to have Fk, and then I'm going to have Fg parallel, and I'm also going to have Fg perpendicular. And then since it's on a surface, there's also going to be normal force, right? So this is one option, or one way of drawing the free body diagram. Someone else can decide to draw it like this, and it's not wrong. Someone can also decide to draw it like this. Then you just use Fg, right? And then you're gonna have Fa on B. Then you're gonna have Fk, and then you're also gonna have Fn. But then the mistake that you cannot make is having both Fg and Fg perpendicular, Fg parallel, all in one free body diagram. So either you do this or you do that. You cannot now, to this one, add Fg perpendicular and Fg parallel. So you can either have the force or the components that represent the force in your free body diagram, right? And then the next question had said, if the system accelerates at 1.5 meters per second squared up the incline, calculate the force exerted by B on A. Calculate the force exerted by B on A, right? So remember I said in the beginning, the force exerted by A on B is equal to the force exerted by B on A, but they're in opposite directions. So I can either calculate force exerted by A on B or calculate the force exerted by B on A. They're going to be the same magnitude but in opposite directions. So since I have enough information for object B, so for object B I have the mass, I have the kinetic frictional force. I am not given the coefficient of kinetic friction, so it wouldn't be very easy for me to calculate the force acting or the force exerted by B on A, right? Because then I'd have to have the F and I need to have the kinetic frictional force in order to calculate that. But in my instance, I can be able to calculate the force exerted by A on B. Since for A on B, I already have the mass, I have the Fk, and I have the acceleration, right? So let's do it together. Then if I want to calculate, now this is question 1.3. F net is equal to MA, right? My net force, what is it made up of? My net force is made up of Fa on B. Remember I said I'm choosing up the slope as positive, right? It's made up of Fa on B minus Fk minus Fg parallel, which is equal to MA. And then I can just further expand on any of the forces that I need to expand on. In the beginning, I had just shown you that Fg parallel can be calculated using Fg sine theta. This is also equal to Mg sine theta, right? So in the place of Fg parallel, I can put in Mg sine theta to calculate it. So I can say Fa on B minus Fk minus Mg sine theta is equal to MA, right? Then I can just substitute once. I can substitute everything once. So this is Fa on B, which is what I'm looking for. the FK I was given is 15 newtons. The mass, is it the mass of A on A or the mass of B that I'm going to use? Remember, I'm regarding the net force for B. So I'm gonna use the mass of B and not the mass of A in this instance. So B is having a mass of 25. The G is 9.8. Gravitational acceleration, the angle is 35 degrees. Mass is 25. The acceleration we're given as 1.5. Right? If you calculate this side, you get FA on B minus 155.63 is equal to 37.50, right? And then you transpose. You have 155.63 plus 37.5. You should get FA on B is equal to 193.13 newtons, right? So since we said that these are going to be equal magnitude, opposite direction, then the question had said calculate the force exerted by B on A. So we've just calculated A on B, which means FA on B, or the one that we're looking for, B on A is going to be equal to negative 193.13 newtons. So we said equal magnitude, opposite direction. So now the negative is indicating that it's going to be in the opposite direction. Therefore, it's going to be 193.13 newtons down the slope. It's going to be down the slope. So in the end, you don't leave your answer as a negative. You have to actually explain what does the negative mean. Remember, the negative is indicating the direction. So you have to state that it's 193.13 down the slope, right? And then the last question for number 1 was question 1.4. The question says, if block A experiences a frictional force of 4.5 when the system was accelerating at 1.5 meters per second squared, calculate the magnitude of the force applied by Nceba, right? So before actually going into the calculation, it's always good for you to draw the free body diagram and work from it, whether you have been asked to draw the free body diagram or not. So I'm going to draw myself a free body diagram for A, right? I'm going to have the force exerted by B on A, which I've just calculated in the previous question. And then I'm going to have the force that is applied by Nceba. And then I'm going to draw the components like I've said previously. I just prefer drawing the components because it's not as easy for me to forget putting in or considering the FG parallel when I'm doing my calculations, right? So I've got FA, I've got FG parallel, I've got FB on A, and then I'm missing another one. I'm going to have F, let me make this dot a bit bigger. I'm going to have FK, right? These are all the forces that are acting on block A. This is for block A. What am I given? I'm given that for block A, the mass I already know it's 10 kilograms. Now they've given me new information. They say FK, they've given to me as 4.5. FG parallel, remember I said we can calculate using mg sine theta. So since we have the mass of A, then we can be able to calculate this one. And then FB on A, we just calculated in our previous question, which means when I consider the forces acting along the line of motion, my only unknown is going to be FA, right? So now I can go on to answer the question 1.4. F net is equal to MA. What is making up my net force? It's all these forces that are along the line of motion. So remember, just stick to the direction that you chose as positive to make life easy for yourself. We chose the direction of motion as positive, right? So FA is positive, and then FG parallel is negative, or in the negative direction. FK is also in the negative direction. FB on A is also going to be in the negative direction, right? Then I said after writing down all the forces making up the net force, then just expand on whichever of the forces that you need to expand on. So FA is what we're looking for, remember. FG parallel, we said, is equal to mg sine theta, right? FK, it's been given to me as 4.5. FB on A, I've already calculated, and MA, I'm given the acceleration and the mass, right? Now I can just go on to substitute once. The mass is 10, G is 9.8, the angle is 35, the frictional force I was given is 4.5, the FB on A is 193.13, the mass 10, acceleration of the system, they say it's still 1.5, right? Then let me quickly do those calculations. So here I get let's put this one first. After doing all of these, then I get 253.88, which is equal to 15, right? Then after transposing, I get 268.88 newtons, right? That's the answer I get. Please do try it out. Like I said, I would just advise that you try out the questions first and then go into the video to see how I approach them. And then if you have any questions, please write them down on the comment section, right? So I'm moving on to the second question. That was the first one. For today, I'm just going to deal with the inclined surfaces, right? Second question, they say a rope is used to apply a force of 240 newtons to a 50 kilograms crate to pull it down a rough inclined surface at a constant velocity. The inclined surface makes an angle of 12 degrees with the horizontal as shown in the diagram below. And then they say state Newton's second law, right? When a net force is applied, remember I said this one is for all of us to get. When a net force is applied on an object, the object would accelerate in the direction of the net force, and the acceleration is directly proportional to the net force and inversely proportional to the mass of the object, right? And then they say draw a labeled free body diagram of all the forces acting on the crate. Now, not to make the mistake of always thinking that frictional force is always acting down the slope, right? You can see here that the motion of the object is down the slope. They say it's being pulled down a rough inclined surface, which means the frictional force is going to oppose the motion. So when they say I must draw a free body diagram, Again, I'd advise you just pause the video and try the question by yourself. When they say I must just draw the free body diagram, then I'm gonna have, that's gonna be 2.2. I'm gonna have the force that is applied, which is down the slope, right? And then I'm gonna have Fk, which is opposing the motion. They said it's a rough surface, so it's gonna have a kinetic frictional force. And then there's gonna be a normal force, which is perpendicular to the surface. Then I'm also gonna have Fg perpendicular and Fg parallel, right? The question had said draw a label free body diagram. Again, I said there's going to be two options there. So this is 4 marks, which means that 1, 2, 3, 4. The marks should always correlate with the number of forces that you have. So I said there's two options for drawing the free body diagrams. Either you can draw using the components of the weight, or you can draw the free body diagram like this, which is also correct. So let's say you drew it like this. Fk, and then you're gonna have Fa. Yeah, that's not very straight. And then you're gonna have Fg, right? You can't have the one free body diagram having both Fg and Fg parallel, Fg perpendicular. Either you have the components, which is this option, or you have the force, which is Fg, which is the option on the right. And then the next question said, calculate the magnitude of the kinetic frictional force between the crate and the surface of the inclined, and the surface of the inclined surface. That's a lot of surface for one sentence. But anyhow, right? The kinetic frictional force Fk, that's what they're talking about, is equal to mu k times n. But I have not been given the coefficient of kinetic friction. So this is definitely not an option for me to calculate the kinetic frictional force because I do not have the coefficient, right? So this one is not an option. This would be the easiest way out usually if I'm given all the information. So now I have to go back and look at the information that I was given. I was given that it's being pulled down on a rough surface at a constant velocity, and then I was given the magnitude of the force applied. It was 240 newtons, right? And then I was also given the fact that it's moving at a constant velocity, so I can be able to say that the acceleration is equal to 0, right? So now if you are to go back to your free body diagram, I'm just going to circle the things that I'm given. I'm given this. I can calculate this using Fg sine theta, and then I'm looking for Fk, right? The acceleration is 0, so which means I can be able to calculate Fk using, let's do it this side, using F net is equal to ma. In my instance, the net force is made up of forces which are acting along the line of motion. Now, I have to choose a direction as positive. I usually say we choose the direction of motion as positive, right? Which I explained in my previous videos is to avoid, sorry about that, it's to avoid the mistake of now forgetting to consider that acceleration is also a vector and also assigning it a negative when it's opposing when you've considered the direction that is opposite to the motion as positive, right? So now if I say F net is equal to ma and I just choose the direction of motion as positive, then I can say the forces making up my net force is going to be Fa in the positive direction, Fg parallel in the positive direction, and Fk in the negative direction are all equal to ma, right? Expand whatever you need to expand on. This is mg sine theta minus Fk is equal to ma, right? And then on this side, now I can just substitute once. The force applied is 240 and the mass is 50 kilograms. G is 9.8. Sine theta in this instance is 12 degrees. And then Fk is what I'm looking for. This side, the acceleration is 0, so ma is 0, right? Then I'm quickly going to do my calculations there as well. So it's 50, 9.8, sine 12. Then we've got the 240 plus 240. Right? I get 341.88 is equal to I transpose Fk. That's the answer I get for Fk. And then the next question says, calculate the value of the coefficient of kinetic frictional force between the crate and the surface of the inclined surface. Again, that's a lot of surface. It's a lot of English right there. But let's carry on with the question. 2.3.2, calculate the value of the coefficient of friction. Remember this one that I showed you? And then I said, yes, we can't use it in that question, 2.3.1. We couldn't use it because we didn't have the coefficient of kinetic friction. Well, the next question is actually asking us to calculate it. So now we've just calculated the Fk from our previous question. So this we have, right? And then the question is asking us to calculate nu k. I said, or I showed you in the first question, that Fg perpendicular can be calculated using mg cos theta. If I am to just bring back the free body diagram for you so you can see, Fg, Fn, remember I explained in the beginning that Fn is equal to mg is not a standard equation. It's just an expression that we get when we look at our free body diagram. So if you look at this free body diagram, you will see that Fn is equal to Fg perpendicular. These two forces are balanced, hence the object remains on the surface, right? So this force is of equal magnitude to this force, but opposite directions. So if I want to find Fn, it's going to be of the equal or of the same magnitude as Fg perpendicular, right? So if I look at, now this question is asking me to say, or is asking me to calculate n. I can calculate n using Fg perpendicular. So I can substitute or calculate it for myself on the side. The mass is 50. The gravitational acceleration is 9.8. Cos 12, right? When you quickly calculate that, it's 50, 9.8, cos 12. I get 479.29. newtons, which means now I have this as well. So now I can just simply substitute and solve for my mu k. My Fk I had calculated previously is 341.88, which is equal to mu k times 479.29. You should get the answer that mu k is equal to 341.88. 1 is 341.88 divided by 479.29. Should get 0.71. And UK has no units, it's a coefficient. So you leave your answer like that. Right, that's the end of my video for today. So like I said, you can also just suggest what kind of questions you'd like for me to cover for exam prep. For this video, I just covered the inclined surface, right? And then we can look at other kind of questions, forces applied at an angle, and all of that as we go along. Thank you for tuning in. See you on the next video.